All right, welcome back. I hope you're having an amazing time so far. Our next speaker is Bruno Giordano. He is a data adoption lead at State Street. Please join me in welcoming Bruno to our virtual stage.
Hey everyone, Bruno Giordano, as Patricia announced me. I wanted to give a quick talk on a reflection of AI from the perspective of traditional data processing. So a little bit about myself. I've been in the IT world for about 30 years now, and training goes back probably that far. And I've recently done some work with AI and started to see the value of it, and wanted to reflect upon it, like what I learned versus where we are now, and hopefully help people gain some other appreciation for this who are maybe getting into it for the first time. So in traditional data processing world, you kind of think of things as garbage in, garbage out. What do you mean by that? If you don't, what I'm trying to refer to here is within data management or data processing, if you don't have good data to start with, you really can't process it, right? That's where the garbage in, garbage out saying often comes from. I want to reflect on a couple of quotes where, we focused as I think as an industry or within a practice. And we used to say, if you can't measure it, you can't manage it, right? So I recently did some research and found out that that's not the actual correct quote. And it comes from Edward Deming, whose actual quote is, it is wrong to suppose that if you can't measure it, you can't manage it. It's a costly myth. So this kind of really tosses that thought of, hey, if I don't have good, perfect data, I can't actually do anything with it. I can't measure it, and I can't use it for analytics and so forth. And that's kind of where I want to start our talk today. Is I want to reflect on that first quote and say, if data, we always used to think data must be complete and have the right level of quality in order for it to be processed and provide information to the user. And I think you'll probably talk to a lot of folks, if you're involved in IT projects and you're trying to do something and say, well, the data's not good enough, we can't actually do what you want us to do with it. So same idea is that if you have bad or incomplete data, it's just not usable, right? And then if you pivot off of that, say, well, what would I do in that situation? Your IT folks, or maybe even your managers, might think that if you have folks managing that data by hand, it's really too costly and too unpredictable. And I'll get into that a little bit about that discussion here, taking a real world example. And this may have happened to you, so hopefully this reflects well. You can think of a senior manager, maybe even an executive, ask for a complete listing of sales by customer demographic. To a senior manager, this is a very reasonable question to ask their teams. Like, look, we're trying to do some analysis and we're trying to figure out who's buying what products and what the customer demographics are. So some of the challenges that you might have experienced that I can reflect back on is might have a sales system which has all your sales data in it. So you have it all in one place, but the customer demographics aren't really required. So if you try to use a shell system to generate this reporting, you're going to get a bunch of blanks and you're not going to be able to fill it in. So you're going to have like big lumps of numbers of sales that you can't attribute to a particular customer type or customer location or something of that nature. So if you try to do that, if you try to get that request fulfilled for that manager, what ends up happening oftentimes, or at least in my experience, is you pull the information together and then you get people, your knowledge workers, usually people who are very busy with other jobs, to drop what they're doing, to come on a best efforts basis and fill in all those blanks and to make the data look consistent, right? And they're using all these things that they know how to do, either their gut or their experience, to help them pull that data together. If they get it done, you present that to the executive, and one of two things happens. Either they love it, right? And they say, oh, geez, we got to do this now on a regular basis. That's going to be really hard to do. Or worse yet, you present that to the executive and they look at it and say, I really don't think these numbers are right. So this is kind of like where where we sometimes find ourselves when we've got incomplete data, and trying to really support that first part of that quote that says, well, if you can't measure it, you can't manage it, right? So one of the things that I was taught going back many years is, well, if you modeled your data appropriately and then managed it, you'd be able to do the right thing. And data modeling, for those of you who are familiar with it or not familiar with it, is and this is a concept used in a lot in relational database design, is you have shared keys, primary and foreign keys, which make connections between things like sales and customer, right? There are constraints, or another thing that get placed in your database design that prevent your data from being orphaned. So you can't have a sale without knowing who the customer is. That's an example of that. Or you can't create a customer record if you don't establish their country of residence or things like that. Those are things that get enforced via constraints. Another thing you do is you do strong data typing. So for example, if you had something like country of residence, you would have a country code, for example, being an example of how you would capture that data. And then you'd say, well, your strong data typing has to be a 3-digit ISO code that's known in my country table or in my country reference information. And then you ensure that you get, for example, country right all the time, and it can't be blank, and has to be a legit country. And furthermore, we do things like create data definitions. So this means when we design our data structures, we give really good business meaning to the information that's captured. So when people go to put it into their systems, it's well understood, right? So that can help when you have a single system and you have control over that system and how it's been designed, and you can maybe solve that problem. But then, the real world is, especially in larger organizations, you may have more than one system for tracking your sales. You could have an online sales system for people who log into the internet, come to your website, and place orders. And that's one complete system. And then you can have contract sales, where you have dedicated customer service folks who work with your customers and set up automatic fulfillment of product on a time frame. Or, for example, every month we're going to deliver a pallet of XYZ to you at this location. And you could have two sets of systems. Now, when your executive asks you your question, that they're not concerned with how many systems you have or how that got implemented. They're really trying to solve a real big business problem. And so, first of all, that's of little interest to them, I think, when they're asking you that question. And one of the other challenges you may have is if these are systems that a vendor provided you, that you didn't build yourself, you can't really impose often your data modeling standards on those systems. So you kind of have to take them as they are, right? Another thing that you could also see, getting into that a little bit more, is you could have different formats for your sales data in your two different systems, and you could have two different representations of customers. So even if you've got good, complete sets of data from both systems, you probably have a challenge matching it up, because they're not going to look the same. They're not going to have the same values. They're not going to have the same completeness requirements. So some things could be populated here and not there. And trying to get that full picture could be very challenging. So what did we in the traditional world decide might be an answer? Well, we've had something called master data management. The idea with those is you take those two different sets of data, sales and customer, you put them in a single view. You actually move them out of the system of record into probably something like a reporting database and or data mart or data warehouse. And you transform it to a single view of how that data looks, right? Now that works. However, the challenges there become you have to then transform the data. And when you define those rules to how to transform it, sometimes that data is going to pop out and you're not going to actually be able to get it in. And then you're still going to have some challenges around how to make that your data complete, your complete reporting, right? So if you think about it, you have $10 million of sales and you can only report on $9 million of it because you can't attribute things back. Again, that doesn't make really anybody happy. So who do you have to get involved? Well, again, you have to get your knowledge workers involved to kind of complete the picture, right? So one thing we can sort of think about is does AI have a hand in this? Like, where can we use AI to help us solve this problem? And AI works pretty well in the sense that, well, let me first start by saying what I first thought when I heard about AI, right? And I was thinking, oh, this is great for new technologies, right? But for the traditional problems I'm trying to solve, it really doesn't apply. You know, I can see this for gaming, facial recognition, but what does it got to do with me? And kind of lastly, I took this approach thinking that, well, you know, people manage data and machines perform operations, you know, as they were instructed by people. And that's really kind of if you think about the traditional way people have programmed applications in the past, it's like you tell the machine what instructions to perform, the machine performs them. If it's not the right thing to do, you get weird results, right? The machine doesn't know any different. But that was kind of, you know, the old world. So let's look back at that original quote again and say, if it is wrong to suppose that if you can't measure it, you can't manage it. And one thing I've kind of learned over the years is that with the right intelligence, even data that's incomplete or in the wrong format can be useful. But so that really is something I think that changed my perspective recently. From the AI perspective, you can have data that's partially complete that still provides you information. And if you have other information, intelligence or information, you can compare and interpret that incomplete data, right? And lastly, if with the right sort of approach, you can use your computers to perform some of this intelligence that you used to have people do, right? So let me give you a simple example of how this might work. You have a delivery system where you have delivery drivers who are dropping product off at a customer. That delivery person delivers weekly order to the following recipient. And look at it, and you can see right here, you have Connors Building, University of Iowa. Side note, I don't know if Connors Building even exists at the University of Iowa, but I'm just kind of putting this out as an example. You see that you have no recipient name, no department number, no street address, no state, no zip, no city, any of that. And you say, well, how's that work? Well, you know, you have a delivery person who knows how to interpret that incomplete data. Because they make weekly deliveries, they manage to get that delivery there because they know the route, they know the customer, they know their job, and you know, they also probably have other deliveries they make, so they are able to say, well, this one goes with these other deliveries. So how does AI work? Well, AI is not really much different. It's learning. It's machine learning in some ways, and it takes having access to lots of data. So if this, going back to this slide, if this was the only customer you had at the University of Iowa, you might be able to get it done, right? This might be able to get delivered. If you didn't have the building name, probably couldn't, right? And if you didn't ever have any experience delivering to this customer before, you can imagine that first delivery might be very challenging to get, but over time, you know, you learn. And that's kind of the same concept with AI. There's learning going on. It looks at things and learns and performs the same sort of intelligence that a human might do, but it has to be taught how to do that a bit. So you have to give it lots of data, right? If you only have one row of data, that's not really going to be very helpful for them. Secondly, you need to give some rules for interpreting some sets of data, right? Once you do that with AI, you can develop new rules by yourself and actually, you know, come up with new ways of looking at things, right? So pivoting that back to that real example, we kind of talked about that, right? Already, where the delivery person makes other deliveries there each week. Their experience tells them where they need to deliver that order. They know who to call when they have a problem. And, you know, because they have coworkers, they probably have phones or radios that they can reach out to other folks who work at the company to find out where do we do with this order? You know, where does this go? And the AI would kind of work in the same way. So, you know, when I dealt with a very large AI project with very lots of data, one of the things that we saw it doing is it compared the data that we had with other data and other internal data, like your other customers. Do you have anybody, for example, who's at the University of Iowa that I can figure out where this order might go? To find out what might be the correct customer record to put this under. All right. It can also look at external data, just like most people probably say today. Well, if I was challenged with Connors Building, University of Iowa, I'd probably pull up my phone. I'd probably enter into a Google search and see if there was a building somewhere on the University of Iowa campus where it would give me an address so I would know where to go and find a loading dock or something like that. That's not really much different in the way some AI engines can work. What it does after the fact is it does what you might do is you'll see some information coming back from that search and you'll say, I think this is the right result, right? So AI in a lot of cases uses higher math. And I'd be challenged to go too much deeper than that because I'm not really an AI engineer, but more of a traditional data guy. But we've used this information. And what it does is it does higher math calculations and it says, hey, this percentage we have a probability that this data matches. And it's of this percent. And we think that's what we consider a match to some good data. Therefore, we can take that incomplete data set and make it into a good data set. And then, taking action from that is your lower quality data. You take that as an input and you produce an outcome, which could be, correcting, at least for the delivery driver, if not for the entire organization, the corrected information for who that customer is in that Connors Building example. And this is what I've seen done in a situation where we were doing customers in the tens of millions of records. Good example case is we had actually 3 systems at this company that tracked customers. You had folks who walked into a store, folks who logged in online, and folks who had that sort of contract sales relationship with the organization. And sometimes those same customers existed in all 3, and sometimes they existed in all 3 multiple times with varying degrees of data completeness. And so how we use the data engine here was we used AI to compare all that data together, compare it to other sources, external sources, and get us a good clean set of, hey, these 5 records are really this one customer. And by the way, here's their correct name, here's their correct address, here is their industry, here is their employee count, there's all these other good pieces of data we want to know. And by the way, here are all their sales across the 3 different systems we use to track them. And that gets you that result, that action of taking that really incomplete data and making it complete and uniform. So if you look at this graphic a bit, you've got kind of this tile here, or this mosaic of tiles that you can see are different colors, different shapes, all thrown together. And that's kind of like if I took all my data of all my customers and their sales and put it all in one place, it would kind of do like this. You can imagine stuff doesn't fit together. It's not structured. Some things are incomplete, and so on and so forth. You take your intelligence, and your intelligence takes all that information in, and out it comes in a very uniform way. And then this becomes much easier for you to do your traditional sort of reporting on that. So just to kind of like bring this kind of to some end here, or to a conclusion, you take the approach of taking AI from a traditional data perspective and kind of going forward is, you can sort of take the approach where you accept your data as it is. You don't need to redesign your data from its system of record. By the way, referring back to that project, one of the things that we noticed, or that came about very often, is a lot of the stakeholders were like, hey, this is great that you're doing this, but don't change the data in my system, because my system operates fine the way it is. If you start changing it, all of a sudden, we're not going to be able to do things. It seems really strange when you have really incomplete data there, but believe it or not, so people and especially people adapt to that, because as you know, we had those delivery drivers and they knew how to do things. It's really interesting how that kind of happens in the real world, and it really makes you shrug when you're a traditional data person who thinks that everything has to be exactly the same. So accept your data as it is. You can perform some AI on that data, And don't rule out bringing in external data, right? Other people know who your customers are as well as you do. Don't assume that no one else knows your problem. And there's data out there that can help you, right? And then you can perform some action with that data once you've actually put it through that kind of an AI processing. You can do that reporting that we talked about earlier. You can decide what to do to clean the data. So, that record with that customer that had just Connor's building, you could put a full address. I don't think that would prevent your delivery driver from doing their job any better. Probably be able to do it just the same. But then you can also do things like, and this is a big part of where we were, the end result of this. Was how do we offer better products or service to the customers that we couldn't really quantify them before. If you know that you have one customer, for example, who has the same demographic as another, and they they buy these products from you, why not, provide that as an option to this other customer who's very much like them and offer them similar pricing, in which case, they benefit and you benefit as an organization. So this is kind of where you can get use out of that. So hopefully that was a helpful introduction from the viewpoint of a traditional data modeler and data management guy. I want to thank you for your time. If any questions, you can certainly reach out to me by email, or we can take them up here. Thank you.
Awesome. Thank you so much, Bruno. That was amazing.
Oh,
if you
really?
can stop sharing your screen, I know the audience wants to give you a huge virtual round of applause.
Oh, thank you.
Thank you. For the audience, it's time for you to make your way to your next session. Along the way, make sure you accept your connection request and take some time to check out our amazing exhibits. Thanks so much, and we'll see you around.